Welcome back. Today we are looking at viscosity. In simple terms, viscosity is fluid's internal resistance to flow. Think of it as a fluid friction. If you pour water, it flows easily because it has low viscosity. But if you pour honey or heavy polymer resin on top of table or anywhere, it flows slowly because it has high viscosity. Physically, this resistance happens because fluid moves layer wise. So when layer rub against each other, because of that, the resistance happen. Here the viscosity, here will be the resistance. So the less velocity it will be having while flowing. And now let's draw exactly what this looks like at a microscopic level. Okay. Now think take one plate. Imagine you have a like solid flat plate, okay, which is still on top of it. Uh, we have a layer of fluid. This is fluid, okay. On top of the fluid, we put one more plate, okay. Now we move this plate at velocity of u, and assume this is no slip condition. So then what happens? The velocity of fluid at the velocity of the layer of fluid at the top of this stationary plate will be zero because this is stationary plate, and the velocity of fluid at the bottom of this moving plate will be u. Since it is no slip condition, the fluid will be moving with the velocity of the top layer of the fluid will be moving with the velocity of this moving plate. And consider the height of this fluid is y. Okay. uh, to pull the top plate, we have to apply a force. That force per unit area is called shear stress, which is denoted by Greek letter tau. Now, Newton observed something brilliant, that the shear stress you apply is directly proportional to the rate of shear deformation, or what we call the velocity gradient. In simple terms, what is shear deformation? Is when you apply pressure parallelly to a resting object, then the object moves layer wise. That is called shear deformation. Okay. And what Newton has observed, he observed that the shear stress was directly proportional to the velocity gradient. Okay, let's write. So the shear stress is directly proportional to the du by dy, which is velocity gradient. If we remove this proportionality and put constant as nu, sorry mu, that is called dynamic viscosity. Okay. Now we will derive units based on formula. So the dynamic viscosity, like as we have seen here, tau is equal to mu into du by dy. So we take du by dy this side. So now mu will be tau by du by dy. We know that tau is basically shear stress. So stress and pressure both units are Newton per meter square, and du is velocity, which is meter per second, by dy, which is distance, so it is meter. So if we cancel meter and meter, then what remains? Newton into second by meter square. In CGS unit, the unit is called poise. So 1 Pascal into second, which is Newton per meter square, is 1 Pascal, and into second. So 1 Pascal second is 10 poise. Okay. Now you will often hear a term called kinematic viscosity. Okay. Kinematic viscosity is nothing but you just divide dynamic viscosity by density. This Kinematic simply represents how easily a fluid flows under force of gravity. Okay, so its units are meter square by second, or it is the one more unit is Stokes. One Stoke is equal to 10 power minus 4 meter square per second. Okay, fluids that strictly follow this linear equation, fluids that strictly follow these linear equations are called Newtonian fluids, like water and air. But what if the fluids do not follow this rule? What do we call that? We call them non-Newtonian fluids. Okay. In next session, we'll understand what are non-Newton fluids, like polymers, ketchup, starch. All these are examples of non-Newtonian fluids. We'll learn about non-Newton fluids in next video. Thank you.